Hello everyone, I wanted to recap what we did a couple of days ago. And we noted that if our function is increasing, then it should be moving upward from left to right, causing a positive slope slanting in that direction. Okay. If our function is decreasing, our function should be moving downward. Notice if you're in a roller coaster ride, you're going down from left to right. You would have a negative slope of your tangent lines. Okay, here's the next one. If your function is constant, okay, you'll note that I have three scenarios provided here. This is the top part of a concave down function. Right at this point, your function is constant. Here at the bottom part of a concave up function, your function is constant. And then here, if all of your y values are equivalent to each other, the function is constant. In all three scenarios, you'll notice that you have zero slope for your tangent line. So that's what you're noting there. Okay. So if your function is concave up, it looks as if the function f is smiling. Okay, if your function is concave down, there you go. It looks as if your function f is frowning. And then the last option that we have that's of interest to us is this one. If you're at a point of inflection, and I gave you a couple of options where you go from concave down to concave up. That's this first option. Or you could go from concave up to concave down. So you're switching concavity. Okay? So I'm going to take a brief look at a problem directly from your notes. So please print it out so that you can follow along. Okay, so we're given this function and they tell us right at the very beginning that you're looking at f of x. So I'm going to put a cloud around this. It'll become clear why I'm putting a cloud around it. Okay, now this is a pretty straightforward problem because everything that you see here says f of x. Look, f of x, 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 and f of x. Okay, all of them revert back to what's described here. So this should be pretty straightforward. Okay, where is your function smiling, right? Where's your function concave up? I would say right here at I. Again, it doesn't have to be the full smile. It can be part of it, a smirk, if you will. And also, I'd say your function is concave up right here at D. So at D, and then I'd say also at I. C says, if you're on a roller coaster ride, when are you coming downwards? So let's see. I say you'd be coming downwards through G, and then also you'd be coming downwards through I. G and I. Okay. 3 says, where's your function constant? This says you have to have zero slope. And the only place that I see that works is at F. 4 says, where does your function have a point of inflection? Where do you go from concave up to concave down? I would argue that it's somewhere in here. And then also somewhere in here. Right? So you can see that you're going from a smile to a frown. And from a frown to a smile. So since I don't have anything marked that I can identify, I have to say it's none of these. Okay, this one says, where does your function have a local maximum? So it's the highest point in its region. B should work. And then also if you go over to F, that is also the highest point in its region. So letter 6 says, where is F concave down? So your function would be concave down or frowning at E, F, and G. E, F, and then also G as in giraffe. 7 says, where is F increasing? So if you're on a roller coaster ride, your ride is going up through A, going up through B, going up through E. So A, D, and E. 8 says, where's the slope of your function undefined? Where can't you draw in a slope? Okay, so it's right here at B. right? So you can see, I mean, would you draw on your tangent line like that? Or would you come in this way and draw on your tangent line? Because we can't decide, we're going to say your slope is undefined at B. And then lastly, it says, where does f of x have a lowest point? The lowest point in its region, right there at C. All right, now ideally I would give you a problem like this where I make it really easy. I label this as f of x, and all of these questions would be about f of x, so it would be really straightforward. But I'm not going to do that because the class requires you to do more complex thinking than that. So we're going to have to start code switching in order to address the type of questions that we answer in this class.